Okay, so this is just a brief introduction to slope fields, okay? If we have a function that looks like this, and you've all kind of written this down. If you don't want to follow this by writing this down, you don't have to. Just watch carefully. So we have this is our function. Now, whether this came from a differential equation that we studied yesterday, we studied differential equations. So if you're given the equation of the derivative and you take the integral of both sides, right? Then you have really the antiderivative, and you have plus c if you don't have initial conditions. And if you don't know what I'm talking about, go back and look at that video. I think you guys might. You guys weren't here. So go back and look at that video. But today, you don't need that video for this. So we have noticed that when we draw something like this, we can actually, and let me just get this set up. Okay. So if we draw the slopes, like I'm going to draw little tiny slopes of tangent lines at various points here. Okay, whoops, there's a slope, a tangent line. That's 0, right? And here's 0. This slope right here, maybe -1, right? This slope right here, maybe +1. Over here is really, really high, maybe like a 10 or something. Slope is 10. Here, 10 as well. Oh, that's quite a ways away. So tangent line, right? Okay. And let's say that's touching. I'll draw one more. Okay, so we have slopes, right? Now, if we're given something like, I don't know what this is, but it's some kind of x cubed function, okay? -2. Let's just say we've got, let's say this, I know this isn't it, but let's say we have something like this. But we don't know what this is. That looks like it's a -2 there, but let's just say that, hey, we have just plus c, right? And this is the solution to our differential equation. Or this is the original function, but I don't know what this is. So what that means is we could have another graph like this. The graph could actually be down here. The constant could be -5 or something. And so watch what happens. Let's draw some slopes of tangents here, okay? At roughly the same x values as before. Okay? Look at the slopes. The slopes look like this, don't they? And then, okay. Now, again, this plus c means that the original function could be somewhere else. So, what about if it's up here? Okay? It's up there. Now, what I'm going to do, you guessed it, I'm going to draw some tangents. Just kind of random tangents. Okay, I'm going to draw these tangents here. Going to make sense, hopefully. These aren't perfect, it's all freehand. But you get it, right? Okay? And just one more, just indulge me here. One more. Let's say that, again, we don't know what the constant is. The original function, really, there's an infinite number of possibilities here for this infinite function, isn't there? And so once again, I'm going to draw some slopes of tangent lines. I hope you're seeing what I'm seeing here. Are you seeing something? Recognizing anything? Well, so really, the slopes could look like that at any point in the graph. Because the c, boys, because the c is unknown, it could be at any one of an infinite number of graphs. Now watch what I'm going to do here. I did that by collecting just 4 graphs. Now, if I do this and get rid of the graphs that I used, look at what we have. Look at what we have. This is called a slope field. I'm going to just put some more on there, so they're not going to be as evenly spaced out. But if I were to make more graphs and blah, 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 right, I would have this. It's called a slope field. All right, and I'm going to do some more here, so on. That is a slope field. And what a slope field is it's a graphical representation of the slopes of really the possible functions that could exist for any kind of differential equation solution. I know it's a lot of words there, but inside there somewhere, maybe the particular solution to a differential equation. So from yesterday, again, you guys have to watch this video here. We had to keep going. You guys were gone. But if we're given initial conditions, like on this original function, there's a point that is 1 minus 1. Oh, okay. So what we do is we plug 1 in for x. We plug -1 in for y, and I can solve for my c. Okay? So what do we have here actually? The c is what? So that's 1 cubed minus 3 equals 1. So -1. 1 minus 3 plus c. So what is this? Minus 2, add 3, it's 1? Something like that? Okay? C equals 1, look good. So c equals 1. So let's say that 1 is about here. So what that means is, let's see if I can find one of those graphs. Well, there was a graph that looked something like this. Wasn't there? Wasn't there? So look how I'm kind of following the slope field here. See that? No, I don't think I dipped down quite enough here, because 1, -1, this would have to go down a little bit more. I'd have to go in more like that. So here's 1, -1 roughly, right about there. So a c, a constant of 1, and a point of 1, -1. That is the particular solution to the differential equation, to some differential equation. So again, today what we want to focus on is the slope fields. And you're going to see the slope fields look something like, a lot like this. And we are going to be able to match these kind of functions here with the slope field. So let me just, before I get too much further, so if you shaved your head, your hair growth would kind of maybe look something like this, right? Little hairs coming out at little different angles. It looks like someone has taken something and just smudged it, right? But you can kind of see, follow the hand here on the screen. You can kind of see these are, remember, these are little tangent lines. They're little tiny tangent lines all over the grid. And so the graph would kind of come like this, and then kind of come like this, and then go up like this, right? And then come like this. So it kind of like looks like that. And it also works up here. See? Could be over there. Or it works down here. Could be down here. So there's an infinite number of possibilities. Given initial conditions, you could probably sketch one. If you knew that this was a point on the original graph, the graph would kind of come like this. Like that. See? So there you go. That's a really complicated one. But lots of times, see, look at this one. Okay? If I can zoom in there, can I? No, not really. So that's a really simple slope field for a parabola, you see? Those would be the little tangent lines on any part of the graph. So that's what we're talking about. Talking about slope fields. All right? Any questions? All right. We are going to, there's your slope field. We're going to get into this question now in our notes, and we'll move there right now. And if you're watching this video, that's just my brief introduction to slope fields. You can watch other videos as we continue on this.